Right, in my last video I said that I was going to attempt to improve the bearing end, this end on the Machifit motor. There's very slight movement on the actual spindle if you really press it hard, particularly with the chuck on when it's extended. You can see there's movement and it causes vibration when you're drilling a bit, and it's not very good for milling in any way. So I'm going to take the motor apart and show you why there is movement and how I'm going to improve it. And I've already actually taken the motor apart, and if you don't use a special tool when you pull it apart, you'll find that the small brushes fly out. They're very small, easy to lose, and they're very hard to actually put back into position again. You have to use a dental tweezer and other tools to actually move those into position, and it did take me quite a bit of time. So I'll show you a special tool in a moment to stop that happening. So firstly, you take off the circlip at the back here, pull off the fan, then there's another circlip. The tool that I use to stop the brushes flying out when I take it apart is just this drilling collar with an 8mm hole, which is the size of the spindle, and a 2BA screw for locking. Put that one over the actual spindle at the back, hold it tight up against the housing end of the motor, and then just lock the screw onto the spindle. That won't damage the spindle being brass. And then you can actually undo the screws to take the housings out. So it's just two long screws that go right the way through the motor, Phillips screwdriver. And that should just pull apart. And if I didn't have that collar on there, that would have been pulled out by the magnet and the brushes would have flown out. And like I said, it's very hard to actually replace them. So the motor housing is made of steel, and there's two very powerful magnets in there glued to the actual diameter. And the motor is very simple in its construction. There's the commutator there, and you can just probably see those tiny little brushes either side. And then on the front and the back you have an 8mm bearing. This one just goes down onto two fibre washers onto a circlip there. And the problem with this one is that they have a rubber boot in the housing end here for the actual bearing to sit in, and that's what's causing the movement. Obviously they've done it to keep the motor quiet and probably stop vibration, but having a rubber boot in there is no good for using this motor for drilling and milling on the lathe like I'm doing. So what I'm going to do is take this rubber boot out. There's a small bent sort of washer underneath that one, and I'm making a brass bush to go in that one to fit the bearing nice and tight, and also the housing, and then I'm going to press it in there and see if that actually improves the rigidity of that actual spindle. So I've just finished turning that brass bush, and I've actually copied the shape of the rubber boot to the same depth and everything, and the actual bearing is a nice tight slip fit on that one, and also on the housing. That one's a little bit tighter. If I actually took that out with the brass in the end there, I could turn it upside down and it wouldn't actually fall out. So that one looks good, and now I just have to part it off, so there's a bit of a shoulder at the back, just like the rubber boot. So now I have a piece of black PVC which is larger in diameter than the end of the housing, and I'm just going to face that off nice and flat. And then I have a piece of PTFE which is the right diameter to actually push the bearing into the housing, smaller than the lugs here, but big enough to actually push that in. And that one actually goes into my chuck at the back on the tailstock, and that goes in nice and square. And then I can just start that off in the housing, put the one up there like that, and use the tailstock to actually push that home into the bearing, into the housing I mean. And that looks really good. And it's good to have the flange on the back of that one, the brass flange, just like the rubber boot, because then you can actually put it onto a piece of PVC with a hole in it to actually push that bearing out. And I have some energy efficient bearings coming, which I'm going to put into this one at a later date. So at the moment I'm only doing the front housing bearing just to see how it goes with the new brass bush. Before I reassemble it, I check the motor housing is thoroughly clean inside, that there's no swarf or anything stuck to those powerful magnets. And then I check the position of the actual bare wires for the actual brushes, that they're not going to touch the housing when it's reassembled, and they're also clear from the actual commutator, so they're in their original position and they haven't been disturbed in any way. And both aluminium housing ends have notches which line up with the steel housing lugs when they go in there, and when they're lined up and in position like that, obviously the 2 screw holes are in line. Plus there's also a cutout at the back for the actual electrical rubber grommet to go into. And when you actually put the motor together, you've got to hold it quite tight. Be careful that you don't actually move those 2 bare wires for the brushes, and it will get drawn to the magnets obviously, and line that one up, and then it will actually get drawn into the housing, and obviously just get that rubber grommet into position and the notch. So that's all ready. And then the front housing end goes on, and that notch lines up and clicks together. And then you come to put the steel screws in. Now if I was to insert those screws, I'll just show you, and try and line them up with this end, it's virtually impossible because the magnets are drawing them to those. And like I say, you cannot do it without using a special tool which is homemade. What I do is I put a very small center drill hole in the end of the screws. I think it's a 5/32 center drill, and just so it touches, causing a very slight angle in that center drill hole. I'll just show you that on the Machifit. Now it's obviously best to use a collet chuck for screws, but I'm only going to lightly do up on those threads, and it's only the front end of the thread that actually catches on those housings. So I've got my very small center drill in there, and I'm just going to do a hole in the end of that one. So because I haven't faced the screw off at all, I'm taking it in very gently and slowly, so I won't actually break that center drill. So it just puts a very slight angle on that hole. Next I have a piece of 1/8 brass, which is about 300mm long, and just put that one in the lathe. And then I use a bit of gaffer tape on each end just to hold those housings in place, because when you push the screw through, it can actually push them out of place. That should be enough. And that's really good stuff. That's outside gaffer tape. So it's just held on like that. Just be careful you don't cover up the actual two external screw holes. And then I put the motor in a vise like this, just to hold it while I'm putting those screws through, give it a bit of weight. And remember throughout the whole process of reassembly to leave this collar on like I've shown. So first the brass rod, the 1/8 brass rod with the point on, goes down from the chuck end. Feed it right the way through, hold it as straight as you can. It won't get drawn to the magnet obviously. Comes to the other side. Insert the point of the brass into the actual center drill hole in the screw, and just carefully push that through, and it will feed into the actual thread hole on the other side. Just give it a couple of turns by finger, and then just nip that one up. Feed that one down, come through the other side. And push that one through, just let it slip through your right hand or whatever hand you're holding it in, right the way through, and just locate it on those first few threads. And I found that's the only way you can actually get those screws to line up. Once it's all locked together, you can take the collar off the back, and just check the spindle spins freely, and then just take the gaffer tape off, and that's the motor reassembled. Next you put the circlip on to stop the actual fan going on too far, and then the chuck. And I don't bother with that circlip on the back there, because the fan is nice and tight on there anyway. Just check that's lined up. And that does actually feel solid. Right, it's ready for the test run now, and I've electrically tested it to see that the casing isn't live or anything. Oh, that's another thing I'd just like to mention. Before actually working on this motor, I should have mentioned this at the beginning of the video, unplug from the wall. The actual switch on the control unit doesn't turn the power off to the motor. I've got it switched off at the moment, and you can see that it's still live. And it's like with anything else anyway, any electrical item, switch off and unplug from the wall first before actually doing any work on it. And for this test I've got a decibel meter. I wanted to see whether it makes any difference on noise, taking the actual rubber boot out. This is a really good little unit, a very low cost. I'll put a link below the video where you can actually buy this one. It's a very handy thing to have in a workshop, particularly if you're doing things like this. So just switch that one on there now. It's also got Bluetooth connection, so you can actually log all the readings on your phone or whatever. And it's got loads of other different modes and that. Runs off of 3 AA batteries, I think it is. 3 AAA batteries. And it's got a tripod mount there, so you can actually stick it on a tripod, hands-free. And it's, like I said, a really good little unit. So that's really good. And this is the motor before the modification. So there's very little difference in noise. I'm not going to do a performance test on a piece of bar at the moment because when I took the motor apart and checked the original bearings, I don't think they're very good. You can test the bearing when you take it out, put it on an 8mm shaft, and if you rock it from side to side, I can actually feel there's excess movement in these low cost bearings. So I've ordered 2 SKF energy efficient bearings, which I'm going to put in front and back. And just before I go, I'd just like to say that if you just want to do the front housing like I've shown, you don't have to take the whole motor apart. You can actually just take the fan off the back like I showed earlier, put the collar up and lock that on the spindle, and then you can actually take those screws out and leave all the internal parts of the motor in place. Just hold the back housing on there when you pull the screws out, and then you can actually just take this one off. If it's a little bit tight, just use a pair of grips very lightly and rock it backwards and forwards until it comes off like that, and then you can actually just do that front housing and try it out for yourself. And as long as you just center drill those screws like I showed earlier and have this 1/8 sharpened pointed bar, then you can actually just quickly put it together again. When you put this front one on, make sure the 2 fibre washers are on there. Hold the housing in at the back and the spindle, and just push that one on, line it up and click it together, and then just use the gaffer tape again just to lock it in place. It's very quick just to do this each time, so you can actually mess about and get that front end perfect. Push the bar right the way through and carefully line it up with the hole at the back there, right the way through. Put the point in the center drill hole and just let that slip through your hand like that again. Couple of threads just to lock that one up. Then lightly do that one up. Same with the other side. And that takes away all the fear of taking this motor apart and doing any modifications. And like I said, it's the only way that you'll actually get these screws back in place again. Lock those up and it's ready to go. Put the circlip on and then the fan. And if you use this collar at any time like I've shown and take it apart, you can actually pull it out and clean the commutator and service the motor properly.